In this video, we will be talking about intervals and inequalities. Now, by an inequality, we mean any expression which involves the less than sign, the less than or equal to sign, the greater than sign, or the greater than or equal to sign. We solve an inequality in the variable x by finding all values of x for which the inequality is true. Such values are solutions that satisfy the inequality. The set of all real numbers that are solutions of an inequality is the solution set of the inequality. Now, graphically speaking, the set of all points on the real number line that represent the solution set is the graph of the inequality. Graphs of many types of inequalities consist of intervals on the real number line. Now, there are 9 basic types of intervals. We went over these in an earlier video, but just in case you need a refresher, we're going to go back over them quickly. So here are the 9 different types of intervals. Here we have 4 different types of bounded intervals. That is, we have the one where it's open on both endpoints, closed on both endpoints. Remember, open means you don't touch those spots. Closed means you do touch those spots. You have the one where, and then you have the 2 where it's a mixture of the open and closed endpoints. Here, unbounded is any interval where you go out to, where it goes out to infinity in either direction. And of course, we have several different options. We can sort of start and go to infinity to the right, whether open or closed. And then there's also the chance that we can go to negative infinity in the left, starting off either open or closed. And then there's also the chance that maybe we go to infinity in both directions. So in other words, we just have x being any real number. So for example, let's go ahead and write inequalities that represent each of these intervals. Then we'll go ahead and state whether the interval is bounded or unbounded. I'm actually going to go ahead and first state whether they're bounded or unbounded, because that's easy to see. The first part is that, again, it's bounded if it doesn't go off to infinity in either direction, and it's unbounded if it does. So here, this would be bounded because it's contained between -3 and 5. It never jumps out to infinity. Similarly, this is stuck between 0 and 2, so this is also bounded. On the other hand, this side goes off to infinity, so it's unbounded. And this part goes off in both directions, so it is unbounded. Now, what about for the inequalities? Well, again, this represents a strict an open endpoint represents a strict inequality, so -3 must be strictly less than x. But x is also less than or equal to 5, because that's a not strict inequality. We could equal 5. Similarly, we could be 0 or 2 or anything in between. And here, we know that x is greater than -3, but that's all we know, because going off to infinity, that means there's no other bound on it. Here, we could say x is any real number, as we did on the last page, but another way to think about this is, which is kind of a dumb way to write it, but that's to say x is between -infinity and positive infinity. So now it's time to have you try an example. So go ahead and write the inequality that represents each interval here. Also be sure to state whether it's bounded or unbounded. On the count of 3, I will reveal the answer. 1, 2, 3. So there are the solutions. For more practice in messing around with intervals, be sure to see the book, page A64, and work numbers 1, 2, and 5 through 12. And in our next video, we'll start solving linear inequalities.